Okay, 10.4. This first question is from a while ago. And because of that, you might not remember some of those things, but it should be a throwback to what we've looked at before. We're looking at graphing this equation. Do you remember the kind of shape that it makes? Makes the U shape, right? What's the P word? Parabola. What's that point called where it all comes together? The vertex. Normally the vertex for one of these is at 0, 0. But because of this x plus 1, where does the vertex move? Left 1. We do the opposite of this for x. And because of this minus 4 at the end, where does the vertex move? Down 4. So the vertex for this parabola would be -1, -4. So if I went on to my graph, -1, -4, there is my first point. For these parabolas, what was always the domain? It could go all the way to the left. It could go all the way to the right, -infinity to infinity. Then what we did to figure out the range is we made a table. We put our vertex right in the middle, -1, -4. We put a couple of points to the left. We put a couple of points to the right. Ran them through the equation to get the y values. I'm not terribly interested in being precise in this one, quite honestly, so I'm not going to put those numbers through there. But what I am going to ask you is, from this vertex, is the parabola opening up or down? Up. How do we know? 2 is positive. This means we're going up. So it's going to go up. It's going to go up, something kind of like that. Again, this isn't terribly precise. If this were a quiz question, I'd expect you to get some better y values. This does allow us to answer the range question, though. The range is the y. How low does this graph go? What's the smallest y value we get to? -4? All the way up to how much? Infinity. I'm seeing in my graph I didn't quite go down to -4, so there we go. This is a parabola. Describe the transformations from the parent function. So from the original parabola that has a vertex of 0, 0, we went left 1. We went down 4. That's the vertex, right? We went left 1. We went down 4. And then that 2 told us that it was going up because it was positive. What else did it do to the graph besides just tell us it was going up? If this is just y equals x squared like this, then y equals 2x squared would do something kind of like this. What do we call that? It went up faster. We call that a vertical stretch. Again, that's because of the 2 that was there. It went up twice as fast. It made it go up a lot skinnier, a lot faster. And that's the parabola. And we spent quite a bit of time on the parabola. Today, in this section 10.4, we're going into graph square roots. And if you could do the parabola, especially with shifting them left, right, up and down, and so forth, the square root graph isn't going to be too bad. It's not the same thing, but it has a lot of similarities to it. So to begin with, let's draw out this parent function. This is the very generic y equals square root of x. There's nothing added or subtracted or multiplied or anything else. What is this parent graph going to look like? When I'm not sure, good idea is to make a table, x and y values. And the question is, what x values should we choose? And we found out, like with the parabola, what x values we chose was very important. We wanted to choose ones that were beneficial. So as far as this goes, what if we plugged in like a -1? And then we took the square root of it. What's the square root of -1? What times itself is -1? Nothing. Can you take the square root of a negative? No. So as far as what x values to choose, don't choose any negatives for this one. Can you take the square root of 0? What times itself is equal to 0? 0. So there's our first point. like the parabola, this one's going to go through the origin, 0, 0. All right, let's try another one. What if you plug in 1 for x?
1.
What's the square root of 1?
1.
1. Great. Another easy point. 0, 0, 1, 1. Go over to my graph, get it nice and started. 0, 0, 1, 1. From this point, there's a lot of things it could do. Maybe it's a straight line. Maybe it curves up. Maybe it curves down. We'll start to see that in the next point we get. What if I plug in 2? What's the square root of 2? What times itself is equal to 2?
1.
Decimal. Decimal. What about 3? Square root of 3. What times itself is 3?
Decimal.
Some decimal again. What about 4? The square root of 4. What times itself is 4? So we chose this number on purpose because the square root of 4 is 2. Back to my graph. Over 4 up 2. I don't want to work with decimals. I really only want to work with integers. So what is the next x value that should be chosen to keep us at working with those type of numbers? 9. That's the next perfect square. So if you plug 9 in for x in this equation, it's saying, what is the square root of 9? Well, the square root of 9 is 3. Over 9 up 3. So what does this graph look like? Well, imagine that Sophia is standing here at home plate. She hits the ball, and this is her launch angle. It kind of launches up like that. Kind of like a half of a parabola on its side, actually. But this is a standard square root graph. I used 4 points for this one. For the future, we're only going to need to use 3. Let's talk about these other parts. What is the domain of this one? Domain is x. For the parabola, domain was everything. What's the lowest x value we can use? 0. Up to how big? What's the biggest x value that we could take? Can we take the square root of 1,000? It'd be a decimal, but sure. Square root of 1,000,000, square root of 1,000,000,000,000, yes. So 0 to infinity. Look at the graph. The range, how low does it go? 0 up to, very slowly, it will get up to infinity. X-intercept. Where does this graph cross or hit the x-axis? 0, 0. And then the y-intercept. Where does this graph intersect the y-axis? 0, 0 again. So the origin is that point. It's where the x and y axis are hit by this graph. So here is your parent function. The square root curve is going to look something kind of like that. Now, as far as the variations go, if we have the square root graph in a form like this, the a value will tell us up or down. What do you think a would have to be for this graph to go up? Positive. So if a is positive, the graph's going to do something kind of like that. And if a is negative, what does it mean for the graph to go down? Well, it's going to hit below the x-axis and look something kind of like that. So the a value being positive or negative is going to tell us what's going on there. What does this h do? What do you think? Think back to what we just did with the parabola. How is that going to impact this graph? Yep. Left or right. And it's going to be the opposite like we did before. What does the k do? So it says plus k. What do you think that's going to do? Think about the parabola again. If you have some number added at the end, like this one, like the -4, what does a number added or subtracted at the end of all of it do? What do we think? Yeah, and it's going to shift it. It's going to shift that vertex in what direction? Not left or right, but up or down. So impacts that vertex by going up or down with it. The domain is going to be from h to infinity. And the range is either going to be from k to infinity if it's going up, or negative infinity to k if it's going down. Top one is if a is positive. The bottom one is if a is negative. The last thing I'm going to put into this table is the table of values. I told you I'm only going to request 3 points for these. I think 3 points gives us enough detail. What 3 points should we use? We're going to choose the best 3 points. 0, 0. If you plug 1 in for the x, the square root of 1 is 1. And if you plug 4 in for the square root of x, it's 2. These 3 points are our parent functions. We're going to move them around based off of what the graphs look like. But we're always going to start with this. So table of values, very important for us. These are the ones we're going to use, and we're going to move around. Not only does the vertex move, like Declan said, but these points are going to move in that same way with it. All right, turn the page. All right, next page, number 1. Graph each equation. Describe each transformation. State the domain and range. Here is our equation. Because of this -3 that's underneath the square root sign, what that's going to do is it's going to take our vertex, that starting point, that launch point from 0, 0, and it's going to shift it right by 3. Whatever the plus or minus is right next to that function, right inside the square root, it's impacting the x, and we do the opposite of it. Also, the +2 is outside of the square root, and we do what it says to the y. So as far as the transformations go, all of the points are going to go right 3 and up 2. There's no number multiplied in front of the square root, so it's not going to stretch it at all. It's not going to flip it upside down or anything. This is the only thing that's going to happen. As far as what is going to be our most efficient way to graph this, if I pretended that it was only y equals square root of x without the -3 and the +2 in there, like this is the parent function again, it would have been 0, 1, and 4 for the x because these are our perfect squares, the square root of 0, the square root of 1, and the square root of 4. But the reality is for this problem, all of these points, and not just the vertex, are going right 3 and up 2. Because they're going right by 3, we have to add 3 onto all the x values. And because it's going up 2, we have to add 2 onto all of the y values. So I told you we only are going to need to use 3 points for these graphs. First point, 3, 2. Second point, 4, 3. Third point is 7, 4. It might be kind of hard to tell, but I'm making my first point, that 3, 2, just a little bit bigger. So now when I'm drawing this one in, I know that's where I'm launching from. So from here, go through those other points. It should have a little bit of curve to it. There's our graph. And that's a good enough graph. It gets us the starting point and gets us the curve of what's happening. As I look at this graph, I should be able to answer the next 2 questions on the domain and range. So the domain is the x values. The smallest x value we have is 3, and it goes to infinity. For the range, the smallest y value we have is 2, and that goes up towards infinity also. One last thing on this one before we move on. How do I know that these points are correct? Well, let me just go and highlight maybe just this bottom one, and let's look at that equation. If you plug 7 in for x, you would do 7 minus 3, which is 4. The square root of 4 is 2. plus this 2 gives us a y value of 4, and that's the y value of 4. So if we plug 7 in, we actually would get 4. I could do the same thing and check these other ones. If I plug 4 in for x in this equation, then the y value would come out to 3. I don't have to do that. That's a quick check I can do. Just by knowing how these things transform, I can take my parent function, my original points, and then just move them left, right, up, or down, and know what the graph is going to look like. Number 2. Number 2 has a little bit more involved because of the number in front of the square root. So transformations. What is this x minus 5 going to do? Notice it's underneath the square root sign. Its location is significant. So what is this x minus 5 going to do? What do we think?
Go right 5.
Right 5. Then with order of operations, the 2 is multiplied by this before we add 3. So the 2, I'm going to tell you that is a vertical stretch by positive 2. It's going to make it go up twice as fast. We'll see that once we put these points on there. So I'm going right next to the x. It's going right by, x is going right by 5. We have this times 2, the vertical stretch by 2, and then the plus 3 is going to make it do what? Up 3. Those are the transformations. Those are the transformations. You start with something, and then you start adding different layers to it to get to the final. Here are my points. 0, 1, 4 for x. These x values are always going to be chosen because these are the perfect squares. If I did the parent function, just like the y equals square root of x, these numbers are chosen because the square root of 0, the square root of 1, and the square root of 4 are those values. And now doing those different transformations that we looked at. The first thing is we said it has to go right by 5. So which values are going to change, the x's or the y's? X's. What do we do with them? Add 5. Then because of this 2 multiplied by that, I said it's a vertical stretch by 2. That means that you're going to take all the y values, multiply them by 2. 0 times 2, 1 times 2, 2 times 2. So we did the first one, we did the second one. Now we have to go up by 3. So you're going to take these y values, move them all up by 3. So add 3, add 3, add 3. Those are our points. First one, 5, 3. Put a slightly bigger point. 6, 5. And 9, 7. My 3 points is good enough. Unlike a parabola where I had 5 points because there were 2 sides to it, this only has like just half of a parabola. So start at your big launching point, hit those other ones, draw your arrow. There is our graph for this one. Answer the questions on domain and range. Look at the graph. What is the domain? What is the range? Domain 5 to infinity, range is 3 to infinity. All right, third one. Here's our equation, and there's not as much going on in this one. In fact, because there's nothing underneath the square root sign, it's not shifting left or right at all. The negative 3 out front is a little weird. It is still a vertical stretch. It's a vertical stretch by -3 though. We'll see how that, like the negative part impacts it in a second. The last thing, the -2, because it's outside of the square root sign, means it's going to go down by 2. So my original parent function is still the same. Hopefully you put those numbers down. Those are always going to be significant for us. Then for the changes. Again, it didn't shift side to side at all, so it's still 0, 1, and 4 for the x's. That didn't change. The vertical stretch by -3 means just like the -3 is multiplied by this thing, we're going to multiply all these y values by -3. So 0 times -3, 1 times -3, 2 times -3. So did that one. Lastly, now we have to shift down by 2, and that's impacting the y's again. So you're going to take all these y values and go down by 2. So subtract 2, subtract 2, subtract 2. Over to my graph, the first point is 0, -2. I'll make it a little bit bigger. Then 1, -5, and 4, -8. Connect those points, and there we go. So vertical stretch by -3. It's moving a lot faster. It's a lot steeper than normal, but then that negative part means it's going down this time. So this one, our square root curve is going down. Domain, 0 to infinity. And then the range. How low does it go? Yeah, all the way down to -infinity, because it's going to keep on going. How high does it get up to? To -2.